So without further ado, I give you the boss of NASA, Charles Bolden, who apparently is going to give us Mars. No pressure, Charles, no pressure.
Thank you so very much. Good to see you again. Thank you very much, Artemis, and thanks to all of you for allowing me to be with you this morning and it kind of kick us off, I hope. I also want to thank Explore Mars as well as the GW President Steve Knapp and Scott Pace of the GW Space Policy Institute for bringing us together for the second annual Humans to Mars Summit. I'm just going to leave that slide up. I'll talk to it every once in a while, and we'll talk about it all day long, so thought I'd let you get used to it. You can always refer to that, and you don't have to look at me. With Mars making its closest approach to Earth last week and currently appearing as the brightest body in the eastern sky during the month of April, this is an ideal time for this conference. As the red planet draws nearer to Earth, NASA, with your help, is drawing nearer to our goal of sending humans to Mars. Sort of as Artemis, I'm surprised she remembered. Maybe I'm not surprised she remembered. But we did talk last year about my three granddaughters, the number one granddaughter being 14-year-old McKaylee, who wants to be the rocket scientist, who has begun telling me that I'm thinking short-sightedly when I talk about going to Mars. She talks about going outside the solar system. So I told her one thing at a time. Let's get to Mars first. During the next 3 days, you're going to get an update on NASA's stepping stone approach to Mars from some of the leading experts at the agency, including Ellen Stofan, NASA's chief scientist, Bill Gerstenmaier, our associate administrator for our Human Exploration and Operations Mission Directorate, and Mike Gazarek, associate administrator for NASA's Space Technology Mission Directorate. And we'll be listening and learning from all of you as you share your thoughts on the best path forward. But let me set the stage by reminding us of why we're all here. While humans have been fascinated with Mars since the beginning of time, there are a number of very tangible reasons why we need to learn more about our closest planetary neighbor. For one thing, Mars's formation and evolution are comparable to Earth's, and we know that at one time Mars had conditions suitable for life. What we learn about the red planet may tell us more about our own home planet's history and future and help us answer the fundamental human question, does life exist beyond Earth? While NASA has been on a path to Mars for decades, with our earlier Mars rovers and orbiters, a critical national policy statement in support of our strategy was on April 15, 2010, during a visit by President Obama to the Kennedy Space Center, where he challenged the nation to send humans to an asteroid by 2025 and to Mars in the 2030s. The U.S. National Space Policy, set in 2011, further supports those goals. And over the past several years, NASA has been developing the capabilities to meet these goals through a bipartisan space exploration plan agreed to by the administration and Congress in the 2010 Authorization Act and embraced by the international space community in the 2013 Global Exploration Roadmap. While robotic explorers have studied Mars for more than 40 years, NASA's plan for the human exploration of Mars begins in low Earth orbit aboard the International Space Station, our springboard to the exploration of deep space. Even as we speak, astronauts aboard the ISS are helping us learn how to safely execute extended missions deeper into space. We're guaranteed this unique orbiting outpost for at least another decade by the administration's commitment to extend the ISS until 2024. This means an expanded market for private space companies, more groundbreaking research in science discovery and microgravity, and opportunities to live, work, and learn in space over longer periods of time. And as most of you know, we're working to return both cargo and human launches to the ISS to American soil. The President's 2015 budget supports the administration's commitment that NASA be a catalyst for the growth of a vibrant American commercial space industry. Already, 2 American companies, SpaceX and Orbital Sciences, are making regular cargo deliveries to the space station. In fact, I think most of you know we had an Easter Sunday delivery of Dragon, and it is now berthed to the International Space Station. Will be there for a number of weeks. While the Russian Federal Space Agency, Roscosmos, remains a strong and reliable partner, later this year, NASA intends to select from American companies competing to send astronauts to the station from American soil. If Congress fully funds our 2015 request, we believe we can do this by the end of 2017. Our next step in deep space, where NASA will send the first mission to capture and redirect an asteroid to orbit the moon. Astronauts aboard the Orion spacecraft will explore the asteroid in the 2020s, returning to Earth with samples. This experience in human spaceflight beyond low Earth orbit will help NASA test new systems and capabilities, such as solar electric propulsion we'll need to support human missions to Mars. Beginning in 2017, NASA's Powerful Space Launch System, or SLS rocket, will enable these proving ground missions to test new capabilities. Human missions to Mars will rely on Orion and an evolved version of the SLS that will be the most powerful launch vehicle ever flown. I've made reference several times now to Earth and the proving ground, and you're here to talk about Mars. So just sort of as reference to my chart, since Mike Gazarik's going to use it, Bill Gerstenmaier is going to use it, Ellen's probably going to use it, and anybody else that comes from NASA is probably going to use it because we want it indelibly emblazed in your brain. We today are Earth reliant. We're dependent on being on this planet. We are not a multi-planet species yet. I don't know whether Buzz is going to talk to you about it later, but Buzz and I agree on a number of things. One of them is that only multi-planet species survive for long periods of time. Here in the Western world, we think very short-sighted, and some of you have heard me say this before. We think about the time in which we're going to be on this earth, or which our kids or our grandkids are going to be on this earth. Many other civilizations think much longer than that, and we need to start thinking that way. We need to remember that we're dependent on a star. The sun is a star. And just like many other stars that we study all the time, and many of you who follow the exploits of the Hubble Space Telescope almost daily get a picture of a star that used to be but is no longer. One of these days, that's going to be the story of our star, the sun. And so if this species is to survive indefinitely, we need to become a multi-planet species. So one reason we need to go to Mars is so we can learn a little bit about living on another planet, so that when McKaylee, my granddaughter, is ready to move out of the solar system, we'll know a lot more about living away from this planet than we know today. So Mars is a stepping stone in the stepping stone approach to other solar systems and other galaxies and things that people have always dreamed of, but frequently don't talk about. So we're Earth reliant right now, and our stepping stone in the Earth reliant system is the International Space Station. I hope I don't need to remind this audience, but I will take advantage of it anyway, because I find that sometimes people don't remember. We have now been on the International Space Station continuously, without interruption, for almost 14 years. Continuously, without interruption, for almost 14 years. Everybody's excited right now because of what's going on in Ukraine. Although I'm cautious, I am cautiously optimistic, because we went through this when the Russians went into Georgia, and station continued to operate the way it is now. We continue to operate just as we always have today with Roscosmos and JAXA and ESA and the Canadian Space Agency and all of our partners. So the ISS continues to move on as our stepping stone to the rest of the cosmos. The proving ground is where we need to go. And so we're going to present our case to you over these next 3 days, and hopefully you will pummel us with questions. I'm having trouble with the lights, but I think I may see Michelle. Are you down there? There's Michelle on the third row. So Michelle Gates is here. I don't see Gerst yet. I know Mike Gazarik was there, but you should pummel us with questions about why we chose this path. There are all kinds of ways we could go to get to Mars, to include those that some people espouse, which is just go right now. Forget about all this other stuff, just go. We don't think that that's the right idea. So we don't think we can just go, but we need to take a measured approach as we go. And so we've chosen an asteroid in lunar orbit as our proving ground, where we can develop the technologies we need to make it the distance to Mars. We can learn how to operate in that environment, because Mars will probably not be like, Mars and its moons will probably not be like operating in low Earth orbit. We're accustomed to, I tell people, I give them the example of when I was a young snotty-nosed astronaut candidate, and I was one once. And I remember going to the Johnson Space Center, and the first time they said, okay, you're going to have a class in orbital mechanics, and then you're going to go over to the simulator, and you're going to fly a rendezvous and learn how to rendezvous and dock. And I said, piece of cake. I've been flying airplanes for 14 years now. I've got, I don't know what I had, several thousand hours. I don't need to learn any of this rendezvous stuff. All you got to do is put your nose on the airplane that you want to rendezvous with and just go. And so first time I got in the simulator, the instructors, they didn't push back. They just said, okay, another little snotty-nosed kid who thinks he knows everything, we'll let him see. And so I got in the shuttle mission simulator and off in the shuttle to rendezvous with a station or something, and I didn't come within hundreds of miles. And it was because I was flying an airplane in the atmosphere that didn't have to worry about orbital mechanics or any of that stuff. And, it seemed like the more I fought to get there, the farther I got away. And then I learned a little bit about orbital mechanics and, how you have to do stuff. Well, when we go to Mars, we're going to find the same problem. It is not like flying in low Earth orbit. We already know that. What we don't know is what is it like flying. So we're going to use rendezvous and approach to an asteroid in lunar orbit, which is a little bit less than our gravity, to try to figure out how do we maneuver out there. And then we're going to, in a stepping stone manner, go out and probably maneuver around the moons of Mars and then figure out, okay, how do we finally get down to the planet safely with human beings? So that's sort of what we talk about, the proving ground, and then on to being Mars ready. And we think right now, with some modest increases in NASA's budget over the years, we're going to be able to get to Mars in the 2030s, as President Obama asked us, or actually didn't ask. He doesn't ask us to do anything. He just tells us, and then we make it happen. A fleet of robotic spacecraft and rovers already are on and around Mars, dramatically increasing our knowledge about the red planet and paving the way for future human explorers. The Mars Science Laboratory, Curiosity rover, measured radiation all the way to Mars and is sending back radiation data from the surface today. This data will help us plan how to protect the astronauts who will explore Mars. Future missions like Mars 2020 rover, seeking the signs of past life, also will demonstrate new technologies that could help astronauts survive on Mars. Engineers and scientists around the country are working hard to develop the technologies astronauts will use to one day live and work on Mars and safely return home. This conference is bringing together the best minds to share ideas about the path ahead. It's important to remember that NASA sent humans to the moon by setting a goal that seemed beyond our reach. With Mars as our focus, we are steadily building the capability to enable human missions to Mars. The challenge is huge. I don't want to fool you. The challenge is huge. If you don't think so, then please listen up as we talk over these next 3 days. But we love huge challenges. We're making real progress right now as a radiation monitor on the Curiosity rover records the Martian radiation environment that our crews will experience. Advanced entry, descent, and landing technologies needed for landing on Mars are ready for entry speed testing high above the waters of the Pacific Ocean in June. Orion is finishing preparation for a heat shield test in December, and flight hardware for the heavy lift rocket necessary for Mars missions is already beginning manufacture in New Orleans. We're counting on the support of Congress, the scientific community, and all of you in this summit to help us realize that goal. The future of space exploration, in my estimation, is bright, but it'll be up to all of us in this assembly to bring the rest of the world along on this great adventure that awaits all humanity. So with that, I'll finish my formal comments, and then, Artemis, do I have time for questions? Can I do that?
Yes, you have.
Great. Uh-oh.
You're now Chris Carberry.
Oh, that's okay.
Welcome to our company.
That's all right. So I think they told me they have mics that way and that way right here. So if you all will come down, I'll try to answer questions that you have. And if I can't answer them, Trust me, there are enough people out here in the audience that I'll let ask. You can answer some of them. And there are 2 mics. Are you all awake? Yeah, come on up.
My question is not directly about Mars, but it's about, human access,
Yeah.
American human access to space. Congress was not especially polite to you the last time you had to testify before Congress. They wanted a contingency plan about how can we quickly get American access back to space. SpaceX thinks they can do it by 2015. I think a possible contingency plan, if we could give them additional funding so that they're not just flying their own crews, but can in fact fly NASA crews to ISS. Do you think that's a possibility?
If we had selected SpaceX now as one of the providers, then I would be able to do that. We haven't selected a provider yet. You may know more than I know. I don't know that SpaceX is the best provider they haven't provided any human-rated vehicles yet, but they're in competition. There's a blackout right now, so I don't know how they're doing. We're going to select the best potential providers, and then we'll go with them. And they may be ready before 2017, but our goal right now is to be ready by 2017. And as I told the Congress 2 weeks ago, the contingency plan for rockets is years away and multi-billion dollars.
Right.
The contingency plan for having an American capability to put humans on orbit is $858 million next year and 3 years away. So that's better than the contingency plan on rockets.
Okay.
They didn't like that answer, I know. But,
Thank you.
There is no instant access to space on American rockets. It just ain't going to happen because we didn't pay attention, years ago.
Yeah, that was a big part of that was Congress as well.
I'm not going to, I don't want to get in the position where I'm blaming Congress alone. It's been a number of administrations. The decision to do this, okay, and I'm going to help some people here who don't remember history. The decision to start this path came in 2004. When we lost Columbia, the Columbia Accident Investigating Board met and gave a report, and one of my predecessors, the NASA administrator at the time, said, I'm going to accept every recommendation in that report. Now, whether that was wise or not, I don't know. But that was the decision that was made back in 2004. And so we started on this path, and I think we've kind of picked it up. We've picked up the pace, at least in the 5 years that I've been the NASA administrator. We only talked about commercial cargo. We now have it. We only talked about commercial crew, and we had no money that the administration put toward it, to be quite honest. Not even a proposal. So, when the president came in, I think the first time we requested, and Congressman Wolf corrected me, the first time in the budget, although we knew we needed $1 billion, I think the first time in the budget, we asked for $500 million, and we got 312. Now, I don't care what Congress says or what staffers say or anything, 312 million is not 500 million, okay? And it's not more than 500 million. So we have never gotten what the president asked for commercial crew. And we really need the support of Congress. And it's my intent to get down on my hands and knees and beg and plead and help them understand that this nation needs our own capability to get humans into space. And we can do it.
Hi, we have no experience whatsoever with gravity, 38% gravity as we have on Mars, with any biological system, much less humans. So at previous conferences, I've heard American folk, European and Russian all say, we need to put a centrifuge on the space station and do something with mice or something. So why don't we see NASA doing that?
Well, because back when the space station was envisioned, and I wasn't here, so I'm going to tell you what I heard. Although the plan was for a centrifuge to be on the International Space Station, it fell victim to what things usually fall victim to, the budget. And so, it just fell out when we looked at how much money was going to be available for station. But we're looking for alternative ways to do it. If you look at that chart, the proving ground, we're going to be orbiting in cislunar and translunar orbit. We're going to be orbiting the moon. And that means that, okay, some people will hopefully take an opportunity to drop out of lunar orbit to the surface. We have commercial partners. We have international partners who are saying, we can't do it on our own, but if you can help us, we think we can get to the surface of the moon. We have challenges going on right now to see if commercial companies or entrepreneurs can put things on the surface of the moon. You know, the U.S. government can't do everything. And I said, our plan to go to Mars is based on the budget that we proposed today with some modest increases in the out years. We are not going to get 4% of the federal budget. So in this group, if you are serious about wanting to go to Mars, then start thinking about reality. And reality is the budget. And we are not going to get 4% of the federal budget to go to Mars or any other place. So we're going to have to figure out ingenious ways to do it based on the present budget plus some modest increases. And I think we can do it. And now you all may not agree, but if you feel we've got to have the Apollo era funding levels, then forget it right now. Don't even spend your time in this conference, because we are not going to get that. You know, people told us we couldn't see commercial cargo. Anybody in here who works in NASA will tell you 5 years ago, people said it won't happen. Some of my predecessors said commercial crew and cargo, forget it. I'm not putting any money. I'll give you $500 million, and that's all you're getting for commercial cargo. And we took $500 million, and we now have commercial cargo. So we're just saying, you know, we got some smart people too. And we do listen to you. And so that's really what we want to hear in the 3 days of this conference, is given the budget realities of today, how do we make that happen? And no, we won't have 4 SLSs out orbiting. I hate this. There are pieces of this chart. Truth be told, okay? Sometimes even we are not real good at chartsmanship. SLSs are not going to be flying around Mars. For those of you, I know there's some purists out here who are going, look, he doesn't even know what he's talking about. He's got SLSs going all the way to Mars. No. SLSs don't go much farther than low Earth orbit. You know, they do like most first stages and second stages and all that. They end up in the ocean somewhere. We do know that. So don't, you know, humor me. Question. Yes, please come. Don't let me talk all this time. Just come right up.
Yes, sir. 2 questions, actually.
Okay.
Sorry. Question 1. What do you say to the public when they say that NASA is dead? That's question 1.
Yeah.
After the space shuttle. This is a popular perception.
Yeah.
And question 2, please speak to education of K-20 and what you guys are going to do to help get your message out to kids.
Sure. When people talk about NASA being dead, I say, you know, I wish I could agree with you. However, we're still working really hard, keeping Curiosity moving all over the lunar surface. We've still got Opportunity, which is a much smaller rover that's really pumping data back. We've got orbiters that are orbiting Mars right now, giving us data. We've got Juno on the way to Jupiter. We've got Pluto, New Horizons on the way to Pluto. We already put Messenger in orbit around Mercury. That had never been done before. We're working with our international partners. There are I don't know, 15 nations contributing monetarily to life on the International Space Station. We now have commercial cargo that's going back and forth to the International Space Station. We have 3 companies in serious competition to carry crew to the International Space Station. We hope to make an announcement sometime end of the summer, early fall. If that's dead, so be it. I can't help, you understand. I am a shuttle person. I love shuttle. It was time for shuttle to go. And it was time for shuttle to go long before we phased it out, because shuttle was not, and I know there's some shuttle people in here. I talk to Bob Thompson all the time. I spent a Saturday with him not very long ago down in Houston over beer, helping me understand why if I just kept shuttle going, we could have used shuttle to get to Mars. That's true. We could have. If we had on-orbit fuel depots and the commercial companies were flying rockets the way that they will do someday, we could have done that. So those of you who are shuttle fans much more than who still think it should be around, I'm not going to argue that point. Like I said, there are 1,000 different ways to do what we want to do. As a Marine, I was taught as a second lieutenant. Lieutenant, make a decision. Because if you don't, the troops are not going to follow you anywhere, and they're going to leave you at the start line. And so they'll tell you your mission's over when they come back and talk about it. We made a decision. Some people in this room don't like it, but we're on our way. And you can either go with us or figure out how to start all over again. And everybody in this room, I think, knows what happened when you start all over again. We're farther down this road than we have been in a long, 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 long time. If you don't want to admit that, I can't help you. But if you stop and think about it, we never had a commercial capability to get anything to space the way we're doing today. We're oh so close to having a commercial capability to get crews to space. And NASA is finally freed up to work with all of you to do exploration, which is what everybody in this auditorium, I hope, came here to talk about. So, get over it, to be blunt. This is the path we have chosen. Help us get it right. I mean, we can tweak it along the way. Everybody knows that. If you don't start down a road, and figure out, okay, we took a wrong turn, how do you ever get to the destination? We can tweak this. I can't tweak just constant ideas with nothing. We now have hardware under construction. We can do this, but I need your help. Question here.
Excuse me.
Okay, that's all right. One more.
Okay.
Michelle will answer them when she gets up, and Bill Gerstenmaier will answer them.
Well, I'd like to put a bug in your ear. There's an example of gravity that could operate on the space station, which has been sitting in the wings for probably a decade. Have yourself or your minions re-examine the Mars gravity biosatellite. It was a joint task between Georgia Tech and MIT years ago. It sits in mothballs. It can be flown on small boosters. It is a little centrifuge full of mice. Yeah. Female mice, in fact.
Is that important?
Well, it is for the statistics of the biophysics. Okay. But it can be parked outside the space station. You don't have to add the centrifuge to the space station. Park it outside the space station, spin it up, take it in and out. Another question that arises...
That wasn't a question. That was a statement.
Well,
if there was a question, get to it, because they're going to pull me off the stage.
The question is, have you considered it?
I didn't know about it, but I will go back and look. And tell me one more time.
Mars gravity biosatellite.
Okay, I got it.
Okay. Second question, is it automatically crazy to imagine more money? We have spent monotonically less in terms of GDP on the physical sciences for 40 years. Yeah. And we're now down a factor of more than 2 over the times of budgets we spent to become great in the world. Yeah. There is no reason I can see why we should not redress that grievance, although obviously it's an uphill battle.
Yeah. No, I don't.
Why not go for the big money?
Well, we're going for the biggest money we think we can logically go for right now. But I just think it's unrealistic to assume that this Congress and any future Congress is going to jump to 4% of GDP. I just don't think. 1%, we may get to 1%. Now, 1% would be like a gold mine.
Indeed.
And I'm not saying, I said a modest increase, but we have to be able to demonstrate that we can do what we said we can do. Commercial cargo was a first step. People said it couldn't be done. We've done that. We got to get the commercial crew, and we've got to demonstrate that we can do it, and we can do it consistently, before we can do anything. We're going to fly Orion in the fall. That's important. That's really important. So step by step. Otherwise, people are not going to, they're just not going to support us, to be clear. Thank you all very much. I really appreciate it. Thank you. Thank you.